So today we're going to be taking notes on the angles formed by parallel lines and transversals. Okay, so we've already touched on those four key angle relationships, and we're going to dive a little bit more deeper into them, showing what their relationships are when they're parallel, which you've already learned if they're congruent or supplementary. But what we want to do now is also make sure we take those relationships and apply it to algebraic problems to solve for unknown variables and angle measures. Okay, so first thing we want to do is just review the relationships that are formed when you have corresponding angles. So when we have corresponding angles, if two lines are cut by a transversal, then by the corresponding angles postulate, so we know the corresponding angles like 7 and 3, 8 and 4, 5 and 1, and 6 and 2, they're going to end up being congruent. So then the angles will be congruent. So the corresponding angles will be congruent. Okay. And the next one, alternate interior angles. Well, alternate interior angles are the angles inside the two lines, like 3 and 6 and 5 and 4. They will also be congruent if the lines are parallel. Only when the lines are parallel. So we've covered corresponding angles. They'll be congruent if the lines are parallel. Alternate interior angles, they'll be congruent if the lines are parallel. However, alternate exterior, these are 2 and 7 and 1 and 8. Those will also be congruent. So the first three, corresponding alternate interior and alternate exterior, they all will be congruent if the lines are parallel. However, the last one, same side interior, and we can also name it by the other way, which is called consecutive interior. You may see either way. These are not going to be congruent, but instead you should have learned that they were going to be supplementary. Okay, so the consecutive interior angles will be supplementary. So the consecutive interior angles will be supplementary when the lines are parallel. Okay. So those are the four angle relationships that occur only when the lines are parallel. Okay. These are also the only way to prove lines parallel by these four relationships here. So on the next side, in example 1, you're given one angle measure in this example here, that this is 72 degrees, and we need to find all the other angle measures. Well, knowing one angle measure will allow us to find all the angle measures, because if these lines are parallel, which they are, I know that because there's an extra weird arrow on the line. When you see that, that means the lines are parallel. Okay, that extra arrow there. Now, if this is 72 degrees, I can use relationships of corresponding alternate interior, alternate exterior, consecutive, as well as vertical angles and linear pairs to find all the angle measures. So if this is 72 degrees, angle E will also measure 72 degrees because those are vertical angles. If this is 72 degrees, then F will measure 108 because they're forming a linear pair. And if this is 108, this will also be 108 because these are vertical angles or a linear pair, linear pair, linear pair. So you should all make sense. All the relationships should work out. Okay, so now that we have that relationships here, we need to find the other angles down here. Well, if this is 72 degrees, by the alternate exterior theorem, I know that A must be 72 degrees because they're going to be congruent when the lines are parallel. So this is 72. And if this is 72, then I can also, again, continue to use vertical angles with these relationship. This means this is 72. Linear pair would mean this is 108. And this is 108. Okay? And we found all the angle measures. By the way, let's just look at the angle relationships and make sure that the ones that we just learned on the previous page are true. So alternate exterior angles should be congruent, which they are. The alternate interior angles should be congruent, which they are. The corresponding angles should be congruent, which they are. And lastly, the consecutive interior angles should be supplementary, which they are. So we know we did it right. Okay, moving on to example 2. In example 2, we have to use the angle relationships to determine what we need to do, set up what type of equation to solve for the variable. So in example 2, we need to solve for x. Well, what you want to do first is identify the angle pair. So looking here, these angles, since the lines are parallel, okay, these angles are inside the two lines on opposite sides of the transversal, which would make them alternate interior angles. So I know that they're alternate interior angles. And I learned when the lines are parallel, the alternate interior angles are congruent. So they are congruent. Okay? And if they're congruent, that means I can set them equal. So I can take x minus 8 and equal that to 78. Then I can add 8 here to solve for it, which would give me 86 for x. And I'm done. So the key to that problem was identifying the angle relationship. Once you knew the angle relationship and the lines were parallel, then you should know what was true about them, that they were congruent. And once you knew they're congruent, then you set them equal and solve. Okay, I'm going to give you a minute to try example 3, and then we'll go over it. Okay, so let's go over to the solution to this example. So in this example, we had to first identify the angle pair, and these angles are on the same position on each line. So if they're on the same position, that means that they're corresponding angles. So these are corresponding angles. And we know that when the lines are parallel, the corresponding angles will be congruent. So to solve for this problem, I would set 2x plus 10 equal to 3x minus 15. And now that we have our equation, we just solve them from there. So you can minus 2x, which gives you 10 equals x minus 15. Then add 15 on both sides, so x equals 25. Any questions on that? Okay, so moving on to example 4. Example 4, we have to solve for x and y and explain what we did. Well, let's solve for y first. If you look here, this relationship doesn't deal with the two lines, it just deals with the one there. This is a relationship from way back. You should know that those are called vertical angles. So, because of vertical angles, which I know are always congruent, I can do 81 equal to 3y. And then solve from there. So divide by 3. So y is 27. And get my solution for y. The next one's a little bit more complicated. Okay, there is no direct relationship here between 6x and 81. You're not going to know it as a corresponding alternate interior, alternate exterior, any of those. But you can find this value here by doing some tricks here. So if this is 81, since these are vertical angles and they're equal, that means this angle here is 81. And so now you know that these angles, you know what the relationship, they're consecutive interior. And consecutive interior must be supplementary if the lines are parallel. So therefore you can add them up to 180. So by the consecutive interior, I know they add up to 180, so it's 81 plus 6x equals 180. So I can minus 81 on both sides. So 6x equals 99. And then divide by 6. So x equals, excuse me, 6 goes into 99. .5 times. Okay, so that's the relationship there with y and x. Okay, I'm going to give you another minute to explain example 5 and do that problem. So by the alternate exterior theorem, I know that the alternate exterior angles are congruent. So I can do 7x minus 15 equals 125. I can then add 15, which will give me 7x equals 140, and then divide by 7, and then x would be 20 for my answer. So again, when you're doing these problems, it's really key that you understand the relationship, identifying if it's alternate exterior or alternate interior, whichever. And then, of course, you need to know that if they're congruent or supplementary. And once you've gotten that relationship down, then you just set up your equation and solve. That's the steps you're taking in these types of problems here. Okay, and moving on to example 6. When is each statement true? Is it always true, never true, only if the line is parallel, only if the lines are parallel? Well, let's go through each angle relationship here. Angle 1 is equal to angle 5. Angle 1 is equal to angle 5. Well, these are corresponding angles, okay? So corresponding angles. Remember, corresponding angles are only equal when the lines are parallel. So the answer would be only if parallel. The next one, 1 is equal to 4. Well, 1 equal to 4. Those are vertical angles. And vertical angles, does it matter if the lines are parallel? Will the vertical angles be equal? It doesn't matter. They are always equal. Whether the lines are parallel or not parallel, these angles will be equal. So this is always. 3 equal to 6. Those are alternate interior angles. Alternate interior angles are only equal when the lines are parallel. 1 equal to 6. These angles are not equal. Okay? They are only supplementary, because if 1 is equal to 4 by vertical, then they will be consecutive, which will make them supplementary. So these are not equal. 4 plus 6 equals 180. Well, 4 and 6 are consecutive interior angles. They will add up to 180 if the lines are parallel. So it's only if parallel. And then lastly, 8 plus 7 equals 180. Well, 8 and 7, that is a linear pair. And a linear pair is always supplementary, whether the lines are parallel or not. So the answer is always. Okay. So again, this is really testing your knowledge of identifying the relationships and understanding linear pairs of vertical angles, that they are not dependent on whether the lines are parallel or not. And knowing that the other relationships are only happen when the lines are parallel. Okay, so in example 7, which lines are parallel and why? And can any line be removed? Okay, well, what you want to do here is you want to look at these lines, okay, and see what is actually given to you. So in here you're given that these lines here, these arcs, mean that they're congruent. Okay, so you got these here lines, which relate to this line and this line, and this line is crossing both of them. Okay, so these lines are both in the same position, which means that they're corresponding angles. Okay, so if they are corresponding angles, it means these two lines must be parallel. So identifying this, or answering this question here, which lines are parallel and why, we know that A is parallel to B because the corresponding angles are congruent. Okay. The second part of this question says, can any line be removed? Well, what did I not highlight in this problem? It was line C. Line C has nothing to do with this problem proving these lines parallel here. It's an irrelevant line. Whether it's there or not there, it's not needed. So to answer this question, line C can be removed. So you're going to try example 8 right now, so I'll give you a minute to try that one. You need to identify what needs to be true about x and z to make the lines parallel, and see if you can remove one of the lines. I'll give you a minute for that. Okay, so as we look back at this problem here, what needs to be true about x and z to make these lines m and n parallel? Well, if these are the lines we're looking at, okay, and this is the line that intersects with both of those lines, the transversal does, x and z would be consecutive interior angles. So they would have to be supplementary to make these lines parallel. So x and z would need to be supplementary to make line M and N parallel. And again, which line did we not overdraw on? We didn't touch line R because it could be removed. Okay, and that moves us to the last example here, which in example 9, we're told that angle 1, in this case, is represented by 2x plus 10, and angle 8 is represented by 3x minus 55. And we want to find the value of x that would make the lines parallel. Well, these are known as alternate exterior. So if the alternate exterior angles are what would make them parallel? Well, if they're parallel, they would be congruent. So if they're congruent, then the lines are parallel. Okay. So what we need to do is set these two expressions, 2x plus 10 and 3x minus 55, equal to each other. And we'll find the value of x that would make that make these angles congruent and thus make the lines parallel. So taking 2x plus 10 and equaling it to 3x minus 55, we can subtract 2x here, which would give us 10 equals x minus 55. Add 55 on both sides, and x equals 65. And get our solution. And that concludes today's notes on angle relationships, knowing specifically what to do when lines are parallel and the relationship among the angles.